Welcome to episode 7. Today we're going to be looking at some calculus features of the Casio Prism. We're going to go into the Run Matrix menu, take a look at some calculus there. And we're going to take a look at graphs and using calculus in the graph mode. I'm going to enter icon number 1. Calculus is put all over the place. One of the quickest ways to get to some of the calculus features is you go under Math, which is F4. First thing, let's take some derivatives here. So I'm going to take a derivative. I'm going to take a first derivative of a quadratic. Let's go with x squared minus 2x plus 3. Toggle over. This is not a computer algebra system. This is not using computer algebra. So it's not going to give me the actual definite integral, but it will give me an integral at a value. Let's find out what the integral is at 2. The integral at 2 is 2. Let's take the second derivative of that same function. X squared minus 2x plus 3. We'll evaluate that one at 6. Not that it's going to make a difference. Second derivative is going to end up the same. What's really nice is if I go up, toggle edit, I'm going to edit that 2, put in a 5, and it changes. So now if my values for the second one were based on this answer, for example, it would also change the value of the answer. Let's see what else we got. We've got the integral. Integrals look like integrals, which I really enjoy. So let's take the integral of something fancy. 1 plus x squared. Limits of integration, I'll toggle over. Limits of integration from between 0 and 1. Execute. My answer turns out to be nice fraction answer with a pi. The pi has not been multiplied in. Again, if I want to change that, I'll change my limits of integration here. Let me delete that. Let's make it a fraction. How about 1/2? Well, I can do this. Put in the 1/2. You notice a couple things happen there. I expanded my integral symbol. This also happens if I use parentheses. When I put in the parentheses around my expression, they will expand. If I use compound parentheses inside, for example, so I'm mounting parentheses one on top of the other, they change color, so that I know I've got a hierarchy of parentheses. Evaluate that. This time it gives me a decimal. It doesn't come out to be nice and even. Summation. Let's take a look at some summation. Again, I get the summation symbol. This looks exactly like it does in a textbook. Let's do something fancy. Let's do the n factorial. So I'll just take any variable, alpha n, go into my options. This is a probability calculation, factorial, toggle over, my variable, what's changing, between what values, let's go between 1 and 8. Execute, there's my answer. Again, this is not a computer algebra system. Under options, I do have a calculus menu. Calculus menu will allow me to solve, numerically solve. I've got my derivatives, which I saw earlier, log of any base. Let's take the log of any base. Log base 3 of negative. You noticed I typed in the minus. I'm going to show you something. 1 over 27. This calculator realizes that that minus means a negative. let's see, what did I do here? Oh, I should not have a negative. I wanted a negative answer. Let's get rid of that. Yeah, it's better. The answer's -3. I got a non-real solution. I could change it to generate imaginary solutions. In fact, let's try that. Let's do the setup. I'm going to go down to turn on my complex mode. I'm going to go in A plus BI mode, exit. Let's see what happens when I type in that negative this time. Type in a minus again, and there's my answer in imaginary mode. Again, I use the minus and not the negative key. Calculator knows the difference, knows that you cannot do any subtraction if I'm not subtracting anything. Let me exit out of this menu. Let's see what this can do with graphing since this is full color. Let's graph a few things. Let's delete that. Yes, I do. I'm going to take my x squared plus 2x minus 2. Execute. I'm going to graph the derivatives of these functions. Where I find the derivative is under Options, Calc. I'm going to take the first derivative of the function above, which is y1. Again, this is not doing it by using any kind of computer algebra system. This is doing simply numerical derivatives, putting them all together all at the same time. I'm going to do a second derivative of that same function. So I can either take the derivative of the derivative, or I'm just going to take the second derivative of the first function, which is y1, evaluated at every value of x. Execute. I've got 3 different colors for the 3 different functions. So let me go ahead and draw my original function, first derivative and second derivative. Now when I trace, I'm going to hop between points. Each one of those is the derivative evaluated. So the derivative of, at that point, the slope of the tangent line at that point, it's calculated. It's 0.3. I can also turn on the derivative if you want to watch that. We're going to go ahead and turn on the derivative. Currently the derivative is turned off. I'm going to go ahead and turn it on. Now what this is going to do is it's when I trace, I'm going to see the derivative at each one of those points as I trace. So when I press trace, I'm going to get an extra piece of information here, which is dy dx. There's my derivative at that point. The derivative at that point should be the same on the red. So when I toggle down to the red, you notice there's the derivative for the previous, the derivative for the next, or what's the value of the green line. When I toggle down, there it is. The derivative of that derivative, if I was to take another one, is going to be 0. So now you see a connection between blue function, the derivative of all the blues are the red, the derivative of all the reds are the green. If I was to take one more derivative, the derivative of all the greens would all be zeros. Alright, so let me go back here. I'm going to delete a couple of these things and I'm going to do some integrals. Because this calculator does integrals like nothing I've ever seen before. It's a single button pushing. So this is going to be a G-solve, which is an F5 key. I don't want to do the roots. I did that earlier in an earlier video. I want to do some integrals, which is a sub-menu. Take the integral between the roots. I don't have to know the roots. It calculates the roots for me. I select the first, toggle over, select the second. There's my derivative. Lower limit of integration, upper limit of integration, the value of the integral, and then the value for the area. You notice it's the absolute value since area cannot be negative. So the value of the integral is negative, but the area is the absolute value of that. That's good, but let's make it even better. Let's take and add a new function. I'm going to go with 1/2 x Oh, let me delete that, even though that one might be interesting too. But I want to have x minus 1. Execute. Let's draw. I want to take the integral between the two curves. G-solve, F6, F3. I want to know the intersection, so it's another F3. Again, it's going to calculate the intersection. Lower limit. Toggle over to the upper limit. Calculate the derivative. Lower, upper, value of the derivative, value of the area. Value of the integral, I'm sorry, and the value of the area. Let's try one more thing. We'll draw this again. This time I'm going to take the integral at just 2 arbitrary points. I want to calculate an integral between 2 points. It wants to know which function do you want to find the integral for. Let's go with the parabola here. Now I'm going to type in my values. Let's go from -3. It'll jump to -3, and I'll go to 5.5. And I've got area, both above and below. And there's my integral. Exit that. Exit one more time. So as you can see, this is a very powerful piece of calculator. Sorry about that. Next week I have had a request to do some videos that include programming. I'll brush up my programming skills a little bit, but next week we're going to be looking at the geometry menu. This has an interactive geometry menu that's in full color. So we'll be looking at that. Also be exploring some conic graphs in the future, along with some conversions and the financial spreadsheets, you name it. We'll have a little bit of everything. Thanks for watching. See Math Run.